Okay, so the directions say that two triangles are possible to solve both triangles. Before I go and I start that problem, I just want to run through again how I can tell that there's going to be an ambiguous case situation, then how to tell whether it's 0, 1, or 2 triangles, just one more time. I know that's not distinctly part of the directions for this problem, but it's something that I feel like is kind of tricky and worth going over one more time. So the first thing I'm going to observe is that this is a side-side angle situation. I know that because I have one given angle, and I'm given the side that's opposite that angle. That's how I know it's side-side angle. Okay there? Next, the ambiguous case happens if I have an acute angle and the side opposite that angle is less than the other given side, which is what we have, right? Because side A is less than side B. JJ, of course. So that's how I know this is the ambiguous case. To determine whether it's 0, 1, or 2 triangles, I'm going to use the law of sines. So I'm going to do sine of angle A over side A equals sine of angle B over side B. I'm going to cross multiply and divide to get the sine B by itself. And then I'm going to look at this value. If this value is greater than 1, I get 0 triangles. If it's equal to 1, I get 1 triangle. Guess there's no plural there. And if it's less than 1, I get 2 triangles. So in this case, that evaluates out to 0.955, which is definitely less than 1, which is why we're getting 2 triangles there. So this was not part of this question, but I wanted to go back and just kind of rerun through why I know there's 2 triangles if the directions did not tell me that there was going to be 2 triangles. Okay with that? So whenever you have an SSA situation, you should see if it's an ambiguous case, and if it is ambiguous, you definitely need to check to see how many triangles you're going to get. All right. So starting this problem then in earnest, so for triangle 1 and triangle 2, the given information holds. So in triangle 1, I'm going to have to find angle B, angle C, and then side C. Similarly in triangle 2. Now just to kind of differentiate these variables, I'm just going to put a little subscript 1 and 2 next to these variables to indicate whether it's a part of triangle 1 or part of triangle 2, just so I don't get confused while I'm doing my work here. Because there's kind of a lot of moving parts in this problem, and it's easy to get turned around about what number goes where. So anything I can do to help kind of keep track of that, I think, is helpful. All right. So the first thing I'm going to do is I'm going to solve for angle B in triangle 1. So just like I did before, when I determined how many triangles was possible, I'm going to use the law of sines. And I'm going to cross multiply, divide, and take the sine inverse. I'm going to do that all in one step. Sam, is it okay that I did that? Compress that all into one step there? Again, the algebra there isn't difficult, but if you don't see what's going on, please holler at me. I'd be happy to walk through it again. But in the interest of time, I just kind of shortcut through some of these things, especially when it's the same steps we've done several times in the previous lesson or something. So when I go ahead and I type that into my calculator, I get 72.7. So that's my value for B1. Now to find B2, it's always going to be the supplement to angle B1. So I can just do 180 minus that previous answer. So that gives me 107.3. Everybody cool there? Finding angle C then is rather easy. I can just use the triangle sum theorem. In each of these cases, but I have to make sure I use the correct value for angle B, since angle B is different in each triangle. So in triangle 1, I have 180 minus 72.7 minus 64. So I get 43.3 there. And in triangle 2, I have 180 minus 107.3 minus 64. So I get 8.7 degrees there. So far, so good. Okay. The last thing I need to do is solve for side C. To do that, I'm going to use the law of sines again. So I'm going to do sine of A over A equals sine C over C. And the sine C here is 43.3. So if I cross multiply and divide, I have 16 sine 43.3 over sine 64. And when I type that into my calculator, I'm going to get 12.2-ish. And then I'm going to repeat the same process in triangle 2. The only difference is that my angle C in triangle 2 is 8.7. Oops, that's C2. So that's 16 sine 8.7 over sine 64. And when I do that, I get 2.7 in my calculator. Is that cool there, Sam? Yeah, it's one of those where the process isn't hard, but there's so many like moving parts, it's kind of easy to get turned around. So those of you that kind of skipped 11 through 14 or did kind of a shoddy job with them, these are problems that it's worth going back and actually making sure you can do and do well, as they're not complicated or difficult, but there's kind of a lot of pieces going on, and it's easy to kind of get turned around. And if you found those to be quite difficult here the first time through, not bad idea to go back and go through them again or make sure that you can do them. Okay. Other questions from this assignment? Yes, Colette. 7. Okay. So on 7, we are asked if we have 0, 1, or actually just that. Yeah, it says are 0, 1, or 2 triangles possible based on the given measurements. So the first thing I'm going to do is identify what sort of situation I'm in. So I'm given one angle, and I'm given the side opposite that angle. So I know this is the SSA situation. And the angle that I'm given is acute, and the side opposite the angle is less than the other given side. So this is the ambiguous case. So I can have 0, 1, or 2 triangles. To determine what situation I have, I'm going to use the law of sines. So I'm going to say sine P over P is equal to sine Q over Q. I'm then going to cross multiply and divide to get sine Q by itself. and I'm going to look at whatever that value is. If that value is less than 1, I have 2 triangles. If it's equal to 1, I have 1 triangle. And if it's greater than 1, I have 0 triangles. And again, when I type these things in, especially when I have to use a fraction and these trig functions at the same time, I like to use that fraction option on my calculator. It makes it very clear to me that I've got things in the right place. I'm not monkeying around with a bunch of parentheses where things can get a little bit squirrely on me. Anyways, when I do this, I get 10 or 1.05-ish. So since that value is greater than 1, I have 0 triangles possible. Is that good, Colette? Okay. Good. So again, I walked through maybe more of that than I really needed to. Based on the directions, you probably could have inferred that that was the ambiguous case already. So like the first couple of steps where I checked that maybe weren't necessary, but if you're just given this and said to solve the triangle, definitely would need to check that in the beginning to know whether you should be looking for, what's going on. So again, I know that's maybe not necessary based on the directions, but I like to do that just to reinforce that as a good habit. If the directions were not so kind, you definitely need to be careful on those sorts of things. Anyone else with questions from the assignment? Okie dokie. We're going to move on today to talk about the law of cosines. So let's say we have some triangle that I'll name ABC. Our law of cosines has 3 different versions, but they're really kind of all the same version. It's one of those things that, like, as a math teacher, it's like kind of silly that we're going to differentiate this, but whatever, it's okay. It's fine. That's definitely the way I look at it. There's never been anything so fine. Oh, you guys are such a bunch of jokers. All right. So I look at this and it looks like 3 different versions, right? I don't bother to memorize any of these 3 versions. All I really remember is that the side that's by itself corresponds to the angle that's in the cosine. The other 2 sides go in the other 2 spots, and I just kind of remember the form. If I look at this formula, this should kind of remind you of something. What does this look like? It looks like the Pythagorean theorem. And that's exactly what this is. It's basically the Pythagorean theorem with a correction factor tacked on the end to account for a non-right triangle. So if this was a right triangle and A is the right angle, the cosine of 90 is 0, so that correction factor just drops off and you're left with a squared plus b squared equals c squared. Yes, Mark?
Why is c not b squared plus c squared?
Oh, yeah, that's a good point. I just wrote things down. It's because I was talking and writing at the same time. Thank you, Mark. Again, if I write something down and it doesn't make sense to you, you're like, why is that? Sometimes it might be right, and I just didn't do a good job of explaining it. Sometimes it's wrong, and I just wrote something down wrong. So please, if you're not sure where I got something or what's going on, do what Mark did there and just ask, hey, what's going on? Because certainly, like, me writing down the wrong formulas, that's a problem, right? Okay. So there's 2 situations that we would use the law of cosines with. And that's if we have a side angle side situation and a side 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 situation. In each of these, we have to be a little bit careful about what we're doing. So in the side angle side situation, when we go to solve for the angles, we want to make sure we solve the smallest angle first. In the side 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 situation, first thing we want to do is make sure the triangle is possible. And then we want to solve the largest angle first. What do I mean by make sure the triangle is possible? What? Yeah, you can't just throw any three numbers together and have them be able to make a triangle out of those side lengths. What has to be true for the triangle to be possible? So it's called the Triangle Inequality. This was something from your geometry course. It was something that's often skated past rather quickly, though. So if you don't remember, it's not that big of a deal. But what the triangle inequality says is the sum of the two legs has to be greater than the hypotenuse. If that's not true, you can't make a triangle into it or make a triangle out of it. In the situation that you have like a tie for biggest side, whatever, either one you can call the hypotenuse, it's fine. The triangle inequality will still hold. Right? For like an equilateral or isosceles triangle, you might not technically have a hypotenuse, but either side can be the longest side and it's still fine. So don't let that throw you. We feel okay here? Okay. So again, neither one of these two make the problem any more difficult, but you do have to remember these couple little details because they're important. If you happen to get a triangle that's not possible, you're going to get frustrated as all heck as to why you keep getting errors on your calculator when you try to do things. It's because you have a triangle that's not possible. If you solve for the wrong angle first in either of these situations, it's very possible you stumble into like an ambiguous case situation where there is no solution to it. Or you get two solutions and the one you actually keep is not the one that you actually wanted. If we follow these directions here and solve for the angles in the order I'm describing, you can avoid all that ambiguity. So, like it takes something that could be kind of a pain in the butt and just really simplifies it. But you have to be a little bit careful. Okay? So let's do a couple of examples here. So our first problem, we're going to solve the triangle with angle A being 34 degrees, angle B equals 14 degrees, and angle C is equal to 17 degrees. So first thing I'm going to do is I want to check to make sure that whether this is a side-side angle or a side angle side situation, because one of them I'd want to use the law of cosines, the other I'd want to use the law of sines, right? So one way you can do that is by drawing a picture. So here's the picture for this situation. Is this side angle side or side side angle? This is side angle side. I can tell because the two sides that are given are the arms of the angle, right? The angle is included in between the two sides. Can you do that without having to draw a picture? Yeah. All you have to do is to make sure that the two sides that are given are not the same letter as the angle that's given. I'll also tell you it's side angle side. Everybody okay there? All right. So, side angle side, what are we going to solve for first? Well, that's going to be the first angle we find, but we can't find one of the angles yet. We need to find side A first. In order to find an angle, you have to know all three of the side lengths. So for the side angle side situation, I have to find side A before I can find any of the angles. So A squared is equal to B squared plus C squared minus 2 times AB times cosine of A. Now I would encourage you to type this into your calculator all in one line. Most of the time I see students making mistakes, it's because they're trying to take or do one of these things in too many steps on their calculator. So notice when I type this in, I'm going to type the square root in automatically because I don't want A squared, I want A. So I'm going to start with the square root, and then 14 squared plus 17 squared minus 2 times 14 times 17 times cosine 34. So I said 34. And so I get about 9.507. Everybody okay there? Okay. Now I want to solve for the smaller of the two angles next. Which one is the smaller of the two, B or C? It's B. How do I know it's B? Because the smaller angle should be opposite the smaller side. Since 14 is less than 17, I want angle B. Everybody good with that? Okay. So, using the law of cosines, I'm going to have 14 squared is equal to 17 squared plus 9.507 squared minus 2 times 17 times 9.507 times cosine of B. Now I'm going to solve for B all in one step. So I want to type this into my calculator all in one line. So I'm going to go ahead and start moving things to the other side. So I'm going to subtract 17 squared from both sides. And then I'm going to subtract 9.507 squared from both sides. And then I'm going to divide by negative 2 times 17 times 9.507. And then I'm going to take the cosine inverse. Is everybody okay with what I did there? I encourage you to do it this way. One of the most common mistakes I see students making on this kind of a problem is they combine all of that stuff together and just make it the coefficient on cosine and just ignore the order of operations there. Very easy to make that mistake if you're trying to do this problem in like a bunch of different steps. I like to do all the solving all in one step. It's much easier for me to avoid making like a silly arithmetic mistake. All right, so let's go to our calculator and type this in. So I'm going to have cosine inverse. Then I'm going to get that fraction command. This is a problem where that fraction command comes in mighty helpful. Oops. And I'm going to use the answer command since that 9.507, the full decimal is sitting right there. So when I do that, I get 55.436. Everybody good there? Okay. How am I going to find angle? What's the last angle I have to find? C. Yeah. So we'll just do 180 minus the other two angles. So 180 minus 34 minus that previous answer. So that gives me 90.564. So those are the three parts that I need. Everybody okay there? Of course. So next example, we're going to solve the triangle where P is equal to 5, Q is 8, and R is 10. Notice since each of those are lowercase letters and there's no degree symbols, they're obviously 3 side lengths. So this is the side, side, side situation. What's the first thing I need to check? If the triangle exists. So to do that, I just need to check that 5 plus 8 is greater than 10. Yep. So we have, this is a possible triangle, so this is a problem we can finish. Okay. So we need to find angles P, Q, and R. Which angle should I find first? R. I should find the largest angle first. So if I use the law of cosines, I have 10 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of P. And then just like we did in the previous problem, I'm going to solve for P all in one step. So I'm going to subtract 5 squared from both sides. And then subtract 8 squared from both sides. And then divide by 2 times 5 times 8. And then take the cosine inverse of all of that stuff. Oh, sorry, R. Thank you. Good catch, Mark. Somebody's paying attention today. Well, this is like the second mistake he's caught right away. You know, I understand that not everybody's in full attention mode every single day. I don't think anybody's probably in full attention mode every single day. All right, so I'll go to my calculator and start entering this stuff in. Is everybody okay with like the algebra and stuff that I've done to get to these steps? Okay. Again, if I skate through some of these little solving steps or whatever and you're not quite sure what I did, please speak up. I'm happy to go back and do some more. I just don't want to waste time doing stuff that's not interesting or not necessary. So there's my value for R. Now that I have R, I can do the same process using law of cosines to find either P or Q, or I could use the law of sines. That's what I would choose to do here. So I'm going to say that I have sine of R over R is equal to sine of, it doesn't really matter for the sake of argument, I'm going to pick P. So if I cross multiply and divide and then take the sine inverse, I have P is equal to the sine inverse of 5 times sine 97,903 over 10. And if I type that into my calculator, I get that P is about 29.686. And then Q is super easy. I just do 180 minus P minus R. And that comes out to be 52.411. Excuse me. So we're going to stop here today. What I'd like you to work on for homework is numbers 15 to 22.